So for the first one, it just wanted you to solve. You should have gotten -1. For number 4, it wanted you to factor. You should have gotten 2c plus 1 and c plus 14. Number 5 was also factoring. You should have gotten 3p plus 2 and p plus 10. So when we graphed our quadratics, one of the things that we looked at was when it crosses the x-axis and when the y value is 0. And so we're going to be using these methods here, just straight up solving equations and factoring to solve quadratics. So if you look down at the bottom, or middle of that page, you see this property called the zero product property. Basically, it says if you multiply two numbers and get 0, then one of them absolutely has to be 0. And that makes perfect sense, right? You cannot name any two numbers that multiply to get 0 if one of them is not 0, right? If you multiply any other two numbers, you're going to get a number other than 0. And so they use this with quadratics to say, well, if I can just get the quadratic equal to 0, then I can maybe figure out what the x's would equal. All right. And so in that first one that we solved for, so when you have something like just a basic equation, like x plus 3 equals 5, you're trying to see what value of x makes that equation true, right? And obviously, we've been able to do this type of problem since middle school. That's going to be x equals 2. And so the truth, that what would make this statement true is 2 plus 3 equals 5. And so that must mean that x equals 2, right? That's what we're doing when we solve equation. What makes the equation true? And so with quadratics, it's a little more difficult because we have an x squared in there. And so we're going to come up with two different answers because there are possibly two answers that make it true. While in the equations that we've solved prior to this, there's only been one answer. You haven't had two answers, all right? And so we did it a little bit with our quiz that we just took when we solved by taking the square root. And that's when we just had a square root and we didn't have to worry about the other things in the problem. Now we're going to introduce it when we have the x squared and the bx that's in there. And so they gave us this example here. The example they've given us is x plus 3 times x plus 2 equals 0. And what they're saying is in order for that to equal 0, the x plus 3 has to equal 0 or the x plus 2 has to equal 0. One of them has to equal 0. And so that's what we're going to use to solve these. So look at example 1. All right, so for this first example, they've set it up for us. X plus 5 times 2x minus 6 equals 0. So that means that x plus 5 has to equal 0 or 2x minus 6 has to equal 0. And so I'm going to have two answers. And so that's exactly what I'm going to do. I'm going to take each of these. I'm going to take the x plus 5 and I'm going to set that equal to 0. And the 2x minus 6 and set that equal to 0. And then I'm just going to solve those. So to solve it, I would subtract 5 from both sides. And so x could equal -5. And my other option here is the 2x minus 6. So I'm going to solve that one. I'm going to add 6 to both sides, just as if I were solving it originally. 2x equals 6. And then I'm going to divide by 2. X equals 3. So my two options here for this particular problem is that x can equal -5 or +3. And then you plug it in. So if I plug in a -5 to solve, just to check it, I can say, well, -5 plus 5 and 2 times -5 minus 6 equals 0. Well, I already know that -5 plus 5 is 0, right? It really doesn't matter what this is, but 2 times -5 minus 6 is -16. Does 0 times -16 equal 0? Well, yes, okay. And the same thing if I plug in a +3. I would say 3 plus 5 for that first group, and 2 times 3 minus 6, and see if that equals 0. That's going to be 8. We have 6 minus 6. 8 times 0 equals 0. Well, yes, that's also true. And so I know that the two answers that I've gotten work, all right? So when you have this type of problem and they've already factored it for you, you're just going to set each group equal to 0 and solve. So go ahead and try check understanding number 1, A, B, and C. Check these. So if you check the first one, you had x plus 7, x minus 4 equals 0. You should have gotten -7 and +4 when you solved those. For B, 3y minus 5 and y minus 2, you would have gotten 5/3 and 2. 5/3 and 2. And for the last one, 6k plus 9 and 4k minus 11, negative 3/2 and positive 11/4. So you do have to reduce the negative 9 over 6 when you get that one. Any questions on those three? Anybody need to see them? All right. So how does this help us then? So this is what we're actually trying to get to. We're trying to get to solving these quadratics. So we've graphed them, right? We can graph this guy. But now we need to know what x values make it true. Just like the example that we used at the very beginning, x plus 2, actually I think I had 3, but whatever, equals 5, right? What value makes that true? That's a 3. What value makes this particular equation true? And it's a lot more difficult than x plus 2 equals 5. We have x squared minus 8 minus 48. That's a lot bigger of numbers here going on. And we have x squared, we have an x, we have all sorts of stuff. And so we are going to use the concept of factoring. And so you'll notice it says solve this by factoring. And so if we can just break this up into two pieces, then we will be able to set each piece equal to 0 and then solve a very simple equation. So we are going to solve by factoring just like we did in the prior chapter. We're going to look at factors of negative 48 that give us negative 8 when we add them up. And so we're going to look at all the factors of 48 and figure out which pairs will work. And so what two factors of 48 will multiply to give you a negative 48 and subtract to give you an 8? All right, so we have 1 and 48, right? 2 and what? 24. Does 3 go into 48? 16, hopefully. Yes. What about 4? 4 and what? All right, so 12 and 4, those will subtract. Specifically, I want a negative 8. So which one needs to be negative to give me a negative 8? Yeah, the bigger one needs to be negative. So I can say this is going to be x plus 4, positive 4, x minus 12, all right? And we can check it really quickly, right? We can say 4 times negative 12 equals negative 48, yes? And 4 plus negative 12 is negative 8, yes. So we factored it correctly, all right? So now this looks just like the problems we just had. And we're going to set each piece equal to 0. The x plus 4 equals 0. The x minus 12 equals 0. And then we're just going to solve. Subtract your 4. X can equal negative 4. Add your 12. X can also equal positive 12. And you can plug it in and check it. You can plug it in and check it. So if I plug in a negative 4 squared minus 8 times negative 4 minus 48, I should get 0. 12 squared minus 8 times 12 minus 48, I should also get a 0 there as well. So go ahead and try check understanding number 2. All right, what are my factors of 12 that give me 1 when I subtract? 4 and 3, and which one's positive if I want a positive one? The 4. So x plus 4, x minus 3 is my factoring. If I set each factor equal to 0, you should have gotten the answers negative 4 and positive 3. Negative 4 and positive 3. One of the things that you've noticed, hopefully, is that these are all equal to 0. Because the whole concept is that if it's equal to 0, then you know that each piece has to, one of them at least has to be equal to 0. And so if you look at that, it's not the next example. Let me fix it. Here we go. If you look at example 3, you'll notice that it is not equal to 0. All right, what do you notice it's equal to? What is example 3 equal to? We have 2x squared minus 5x equals 88. We do not have a property that tells us numbers that always equal 88. So for this one, we have to make it equal to 0. So basically what you're going to do is you're just going to move that number over, all right? Now, I will say they gave us huge numbers for this one, and I will not give you numbers this big, but you're going to move this 88 over, all right? On the right-hand side, it just cancels. On the left-hand side, it does not combine with anything. So there is no common factor or common term to negative 88. You don't have just a number over there. So you would say 2x squared minus 5x minus 88 equals 0. Now, when I taught you the method of rainbow, this is not one that I would do a rainbow on. Why? Because we have 2 times 88. We're going to get this huge number with a ton of factors. And so if I give you one like this where you have to do multiply across, I'm going to give you smaller numbers. You can do it in pairs if you want to, because it actually works out fairly easily. But when you do it in pairing up, you have the only numbers, the options are 1 and 2, right? And for 88, there's a lot of options. You know, you could have 4 and 22, right? And I think we end up using 8 and 11, which is the one that kind of stands out. So we're looking for pairing those up and equaling 5. And so you end up getting 16 minus 11. So you end up getting those pairing ups there. So you know you're going to have 2x and you're going to have 1x. The 2 needs to multiply to the 8. The 1 needs to multiply to the 11. And then you want it to be a negative. So you want the bigger of the 2, which is actually the 2 times 8, to be the negative. If you'll recall, when we did this, I would give you something smaller, like, right, and then you could just multiply across and do your grouping, which is what you're about to do. But for this one, I wouldn't multiply across to get that huge number, because you'll never find your factors of something that big. You'll have to just pair them up like this. But I'll give you smaller numbers so that you can just do the rainbow method or this method if you want. Once you factor it, so the key thing here is move your number over, and then you're going to factor it. So don't get lost in the huge factoring. You're going to move it over so that it looks like all the ones we've been doing, and then you'll factor. And then the process is the same. 2x plus 11 equals 0. X minus 8 equals 0. You can have fractions just like we did earlier. Subtract your 11. 2x equals negative 11, and then divide by 2. And so one of our answers is negative 11 halves. You can leave it as a fraction or a decimal. And on the other side, you would add your 8. So our other answer is x can equal positive 8. And so once you get it moved over and factored, you're going to do exactly the same thing, so that you will have 2 parentheses and set each one equal to 0. Equation, or any of these that you're solving by factoring, your first step is to make sure that it is equal to 0. If your equation does not equal 0, you have to fix that. In this case, this does not equal 0, so I need to add my 36 over. And so I'm going to say x squared minus 12x plus 36 equals 0. Once you've done that, you want to factor it completely. So this means if you have a common factor, take it out. If you have to just look at your last term, then look at your last term. Or if you have to factor like multiplying across, but you want to factor it completely. And so in this case, I'm looking for factors of 36 that add up to 12. And this happens to be a special case. So when you factored this one, you would have gotten x minus 6, right? And so once you have factored it, your next step is to set each group equal to 0 and solve. All right. And so in this case, you actually end up with the same answer twice, and you don't have to list it twice. For both of these, when you solve this, you are going to get that x equals 6. You don't have to list it twice. When we get into higher math, there's going to be actually a name for this. a repeated 0, and you have to tell me that. But in this case, you just have to say x equals 6, and that would be your answer. For the first one, it was already factored for you, so you just needed to set each one equal to 0. You should have gotten x equals -8 and -1. For 2 and 3, you just had to factor using the last term that adds up to the middle. N squared plus 11n plus 24. You should have gotten factors x plus 3, x minus x plus 8, and you would have set those equal to 0 and gotten -3, -8. For 3, you were looking at factors of 36 that add to give you 12. You would have gotten x or b minus 4, b minus 8, and then when you set them equal to 0, you would have gotten +4 and +8. And then for the last one, you would have either multiplied across or set up your pairs. But when you factored this, you would have gotten -3/2 and -2 as your answers. So you would have gotten a plus 2 and then 2a plus 3 for the other factor. Does anyone need to see any of that factoring?